Hi guys, so today we're doing Course E Lesson 1. So some of you may have coded with me before. This is based for fourth graders, but hopefully you guys have been coding with me, so you're ready to do this. So how do you guys think you fix something that's not working? And do you follow a specific series of steps to figure out what happened? We're going to do some of these puzzles, and some have been solved for us, but they have bugs. And remember, a bug is an error in a program that prevents the program from running as expected. So in order to debug, which basically means finding and fixing the errors in the program, we have to find the bug itself. So we are going to watch a couple of videos, and we're going to do our puzzles. And I'm excited to have you guys here. Sorry guys.
Today, we're going to learn about pair programming. In pair programming, you work as a team.
Why should two people use one computer?
Why should two people use one computer? Because two heads are better than one. We work together in an interesting kind of way.
Because we're interesting people.
We are interesting people.
In pair programming, you and your partner are going to sit down together at one computer and you are both going to work on the same project.
Right now, we're working on Code Monsters. Oh no, a fire monster. We don't have enough time. I'm sorry. We'll get to it later. In pair programming, one person is the driver and the other person is the navigator.
Just like driving a car. Your choice, driver or navigator?
Driver. The driver sits at the computer and is the one using the keyboard, mouse, or touchscreen and controlling the main actions of the computer. I'm setting all the arrows so that they make the character move in the direction he's trying to move.
The other person is the navigator. The navigator helps the driver by answering the driver's questions and pointing out potential problems or mistakes. Go left, and then instead of righty-tighty, go right. Communication is key to a successful pair programming.
No insults. Be respectful. Don't be a bossy navigator because nobody likes a backseat driver.
Here, why can't you do this?
Wait. Hey, stop that. Give it back.
Wait,
That's not nice. Give it back.
Just one thing.
Communication is key to successful pair programming. Did the cat say something after?
You and your partner should always be talking.
Okay, so there's the cat.
The driver can explain what she or he is doing. Do you think it would ruin it to type something extra? And the navigator can help suggest what to do next.
Can you write a program that makes the dog move to the target? The navigator should be thinking about the big picture.
And the driver focuses on the details.
Both roles are important.
Want to switch?
Okay.
I'm the driver now.
Be sure to switch roles often.
Okay. Wait a second. Why isn't this working?
You need to attach it up there. Look, there's a hole.
Did you see how my partner helped me figure out the puzzle on fewer tries? She caught my mistake.
Yay, good job!
Pair programming is all about working together
As a team.
So we used to be able to utilize the paired programming, but we can't do that right now with COVID. So, but if you're home with your family or you have a friend over, you guys can totally do paired programming together as long as you're safe. So don't be bossy, share the computer, share the keyboard, and switch roles often. So we are going to go over a little debugging recipe before we start our puzzles. And this is debugging, which requires us to find the bug and why our program won't work. So to avoid mistakes, read the directions. Ask yourself, what's the goal of the puzzle? Take it slow and one step at a time. And can you talk about the problem in your own words? A lot of you guys found that it helps to talk to somebody else or a classmate in order to figure out a puzzle when you guys get stuck. Were you given any codes to start? What does it do? And why do you think it's there? So for debugging, you need to look for problems in each step of the way, describe what is supposed to happen, and then describe what's going wrong. Does the difference between what's supposed to happen and what did happen give you guys any clues? Usually, that's how I can find a bug, is I know what should be working and then what is not working, and I can figure out what went wrong. The next tip is find one thing at a time and describe how the results changed. Try leaving breadcrumbs in your program. This means you can put clues inside your code, like having a program say something to let you know when each chunk runs. Try doing each task on its own chunk, then put all the pieces together at the end so that it's easier to see what each thing does. Talk to a friend. Maybe you or your classmates can help figure out where your plans went wrong. And then try at least 3 ways of fixing the problem before you ask. So we're going to go on to our puzzles. We have a video to watch, and then we'll do more.
Today, we're going to learn to program using a drag-and-drop language called Blockly. Blockly uses colorful instructions called blocks to build programs that you can use to solve puzzles. Under the hood, you're still creating code. Each puzzle you'll solve with the code is split into 4 main parts. On the left is the play area, where your program will run. In the center, you will see the toolbox area that holds all the blocks that you will need for each puzzle. To the right is your workspace, where you will drag blocks to build your program. Finally, above the workspace, you will see the specific instructions for each puzzle. Don't worry if you accidentally drag out a block that you don't need. If you have an extra block, simply drag it back into the toolbox to put it away. After you hit run, you can always hit the reset button to get your character back to the start so you can try again.
All right, so we're going to start our puzzles. And you can read them, or you can click this.
For this puzzle, snap all of the blocks together and click Run to watch it go.
All right. So all of our blocks are snapped together, and it wants us to hit Run. That's this button over here. All right. So that one was done for you guys. Drag an extra move forward block out of the toolbox, then attach to the win run blocks to finish your code. So we're going to grab this and drag it there, and we're going to hit run. Pretty easy, right? Okay, now you did it. Now go find the pattern in your code and take out the extra block. You can only use 3 of these move forward blocks. So now we have too many. So it wants us to take one out, and now hit run. Because right here, it shows you exactly how many blocks they want you to be able to use. So we can only use up to 6 blocks.
Use the blocks in the toolbox to build your program. Get the bird to the pig.
Okay, so you need to get this bird to the pig. And it's kind of like a visual grid with these blocks. So you guys have the ability to count how many squares he needs to move over and then in the right direction. So just quickly pause me. And when you're ready, hit unpause so we can see how our algorithms look. All right, guys, how did you do? This one is fairly easy. I hope you played around with it until you figured it out. These are the steps that I'm going to program my bird to take. I haven't run it, so I don't know if there's a bug or not. Okay, we did it. So under the hood, this is what coding looks like. This is what you're telling the computer to do, and so this is what the computer is understanding. We are using Blockly because it's easier for humans to read. So let's keep going.
Help the bird get to the pig. There is one extra blue move forward block. Throw away the extra block by removing it from the other blocks and dragging it back to the toolbox.
Okay, so this one is fairly easy because it's telling you there's one extra blue move forward. So in our algorithm, which one is the blue move forward we have to throw away? Right. But let's just run it and let's see what happens if we don't take it out. We blew our bird up. So we need to toss that one. And now let's see how we do. Good job, guys. Let's keep going. And we have a video.
All computer scientists, no matter how experienced they are, run into errors that they need to fix. This is where debugging comes in. Debugging is just a word that means finding and fixing errors in a program, and the first step towards fixing errors is to find them. Most puzzles have a step button below the play space that you can use to hunt for problems. If your program doesn't work, press the step button and see what happens. Does the character take action in the right way? If everything looks good with the first block of code, press the step button again. How does everything look? Is it still running right? Keep going through your code, line by line, until you find the first place where things go wrong. What happened? What was supposed to happen? What does that tell you? In this puzzle, I get to the last line of code and don't reach the goal. What happened? I got to the end of my code without solving the puzzle. What was supposed to happen? I need to go forward one more step. What does that tell me? It tells me I need to drag out one more of these blocks and attach it to the end before I click run. Ta-da! That's how you debug a program.
All right, we have to use our debugging skills to get Scrat to the acorn. So let's hit run right now before we do anything, and let's just see what happens. He fell off the ice. So right here, here's the step button they were talking about. This is the button that is so helpful when debugging, because it allows you to move step to step to step to see exactly what and when your program gets messed up. So we're going to hit run. Not run. We're going to do step by step, and we're going to figure out where we messed up. It's highlighted right here for you guys, each step. Do we want him to turn? Nope. So there's our bug right there. Some of you may have seen it even before you figured it out. So now let's hit run. That gets us to this ice right here. So we want him to move forward 1, 2, The broken ice gets us in the water. So let's do that. 2 move forward blocks. And where's he need to go? Right, he's going to turn right. And how many times does he need to move forward? 1, 2. So he's going to move forward twice. Let's snap those and let's hit run. It's really helpful if you either touch the screen to try to figure it out, your blocks, or if you guys write it down on paper, or if you talk to a friend. Kind of helps break it down a little bit. Okay.
Trace the path and lead me to the acorn.
All right, so we need to get him to the acorn. How are we going to get there? Right, he needs to move forward 1 time. Then where's he need to turn? Right. So he's going to end up right here. Let's use it step by step so far. He's moved forward and he's turning right. Now we need him to move forward again. And now where do we want him to turn? Right, to the left and then move forward. Let's see if that got us to the acorn. Good job. We did it. So every lesson is going to get harder. Like right now, some of you guys are probably thinking, oh my goodness, this is boring and dumb. But you guys need to know how to do the basics before we get into more harder courses.
Someone has their directions mixed up. Can you help?
Let's run it and let's just see what happens. Okay, so we saw Scrat. He falls off the ice in the second move. So what do we want him to do? No, we don't want him to turn. Let's see. He moved forward. Now we know that we don't want him to turn right because he fell off. So let's turn left and see what happens. Oops. Oh dear. What are we gonna do with him? Do we want him to turn right? Do we want him to move forward? We definitely have a bug in here. Okay, so we have moved forward. And we're turning right. Again. But when we do right, he falls off the ice. But when we do left, let's step by step again. Well, it worked that time. The first time we did it, he still went off the ice, which was kind of weird. So now what do we want him to do? Move forward. And here we go again. He just turned left. So where's he looking? Right, towards the water, which means he's going to jump in. So we need to fix that and turn right. So let's reset him and let's run it and see if we got all the bugs. Good job, guys. So we have 1 extra block, which you can see because we're using 10 out of 9.
Figure out what is wrong and get Scrat to the acorn.
All right. So I want you guys to pause me for a minute, and I want you to work on this. You can talk to a friend or a family member, or you can write it down on a paper with arrows to try to figure it out. And when you're ready, unpause me so we can see the solution. All right, guys, so this is what your algorithm should look like. It's okay if you couldn't get Scrat to the acorn. I had to change the direction he needed to hop in, and I took out one extra move forward block. So now I'm at 9 out of 9 blocks. So I'm going to hit run and we'll see how we did. All right, we did it. So we're going to keep going. And we are at a challenge puzzle. And challenge puzzles help stretch your brain. So these ones are a little harder, but I think you guys are ready for a challenge anyways. So let's hit I'm ready. Okay, so your challenge is this.
Challenge. Debug this level by rearranging, adding, and deleting blocks.
All right, so there could be a lot of different possibilities that we need to do in this one. We might be adding blocks, we might be taking away blocks. So we're gonna need to figure that out as we go. So I'm going to have you guys pause me because I think you guys can do this. And when you're ready, you can unpause me and we'll see if we got the same steps. So good luck, and I'll see you in a minute. All right, guys, how is your challenge going? Was it too hard, too easy? This is what I came up with. I think I got it right, but I won't know until I hit run and play, so let's do it. Did it. Did you guys run into any bugs where you felt like you needed to change something, a step in your algorithm, or did you get it perfectly right the first time? Okay, count the spaces on the grid carefully. So we have 1, 2, 3, 4. So we can put 4 move forward blocks. And then where do we want him to turn? Right. So that's going to end up with him right here. Now we want him to go forward 1, 2, 3, 4. 4 more times. Okay, so now we've used 10 out of 10 blocks. Let's hit run. And we did it. So some of you guys, if you're familiar with coding, I want to go back because I want to show you. We can do it like this, or we can scratch that, and we have this block right here. We want him to move forward 4 times. I don't expect you guys to use this block yet, only if you're comfortable, and it just saves you steps. Oops, I forgot a step right here. So right now he's going to move forward 4 times. 1, 2, 3, 4. He's going to turn right and move forward 1, 2, 3, 4. Oops. How did I hit 4? It doesn't want to let me change it. Okay. So now I've only used 6 out of 10 blocks. So it just cuts down on the amount of steps. And we did it. So it's okay if you didn't use that, but we'll be working with that in the future.
Help Scrat get to the acorn.
All right, guys, I want you to do this one right now on your own. So go ahead and pause me, and then we'll figure it out together in a few minutes. It's okay if you get frustrated because you can always throw blocks out, add blocks, change the direction. And don't forget, you have the step-by-step button to help you debug. All right, see you in a few minutes. All right, guys, how was that one? we are going to run it and see if we're right. Now, in coding, when you use the repeat block, it'll do it until it repeats itself that many times. So look for patterns. I see a pattern in ours right now. Move forward, turn right, move forward, turn left, move forward, turn right, move forward, turn left. So we have a pattern. So in this situation, this is when it's good to use repeat blocks. But right now, they're not asking us to use repeat blocks. So we've used 12 out of 12 blocks, so we're perfectly fine if we didn't use the repeat block. And we did it. So let's see what it looks like without all the extra moves. Do those look the same? Move forward, turn right. Move forward, turn left. Move forward. Okay, let's see. And let's stop this in there. How many times do we want him to do it? Move forward, turn right. That's one. Move forward, turn right, and left. Oh, shucks. Sorry, guys. Move forward, turn right. Move forward, turn left. Move forward, turn right. Move forward, turn left. So we want to do it twice. Got cut way down on our amount of blocks. So let's hit run and let's see what happens. Oh man. So we have a bug right there. So we can fix it. But you get the idea that we want to use these in order to keep going. So next we are going to, oh, I'm still in it. We're going to be drawing with loops. Oh, I love this one. This one is super, super fun. So we're going to get to draw and create some art on here, which is really fun. So I hope you guys had fun today, and I will see you next time. Bye.